In this lesson, we're going to be looking at how we can prove triangle congruence using two new theorems. And those new theorems are angle-angle-side and angle-side-angle. We're continuing to answer that question, how much information do we need, and do we have enough information to prove that two triangles are congruent? The first theorem we're going to look at is called angle-side-angle. And it says, if two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. So we've talked about included angles, but we haven't talked yet about included sides. And so you'll notice here, if you look at this triangle, BAC, that we have angle C is congruent to angle F, and angle A is congruent to angle D. And the side that's marked congruent is the side that connects those two angles. That's where the included side needs to be. And you'll notice when we talk about angle A and angle C being congruent, or angle A and angle D, and then you have angle C and angle F being congruent, those are also the letters that are used in the names of the sides when we look at them. But the best way is to look at the picture and make sure it's the side that connects the two angles that you're talking about. And if you have that, then the two triangles are congruent. So this is something we can use to prove triangle ABC is congruent to triangle DEF. The other theorem we're going to talk about is angle-angle-side. And you'll notice this time you have two angles and a non-included side. So when we have angle A congruent to angle D and angle C congruent to angle F, you'll notice it is not this angle that connects, this side that connects them, that is being marked congruent. It's over here and over here. It could also have been, if we had it, I'm just going to draw the same triangles. Instead of being BC, it could have been AB, congruent to DE. When we're using angle-angle-side, we just can't use, we're not using that side that connects the two angles, the included side. So we have two more theorems here that we can use to prove triangle congruence. So we're going to look at these, and it says, can the triangles be proven congruent with the information given in the diagram? So if you look at A, you've got a triangle right here and a triangle right here. And we have these sides marked congruent. We have this angle marked congruent to this angle. So right now we only have one angle and one side. But then we're going to keep looking into that diagram and see, do the triangles share a side, or maybe do we have vertical angles? And here you'll notice we do have vertical angles, so we know that those two are congruent. So we have two angles and a side on this triangle, congruent to two angles and a side on this triangle. The question is, where is the side? So are we using angle-side-angle? Is the side connecting the two, or is it angle-angle-side? Since our side is over here and it's not connecting, let me erase this. We've got a lot of drawing going on. We had this angle and this one. Since we didn't use the side that connects them, it's going to be angle-angle-side. The next picture we have, it certainly looks like we have two congruent triangles, but at this point, let's see, what do we have? We have this angle congruent to this one, this angle congruent to this one, and then we have these two vertical angles that are marked congruent. So we have three angles. Is three angles enough to prove the two triangles are congruent? Well, all of the theorems we've learned so far, you had to have at least one side. And if we look at this, we don't have any reason to think any of the sides are congruent. It doesn't tell us anything. So no, we don't have enough information because we're missing a side. And then the last one, we've got these triangles. And let's see, we have this angle congruent to this one. And then we have this angle over here congruent to this angle here. So we do have two angles. And now we're looking for a side. Do they have a side that's congruent? None of them are marked congruent. So we want to look for something like the reflexive property. Do they share a side? And if you look right here, both triangles seem to have this side in common. And one way you can test that is to grab your highlighter and to outline the two triangles that you're talking about. We have this triangle, and then we have this triangle. If you go over that same line again, you're going to be able to use that reflexive property to say that side is congruent to itself. Now, in order to decide what it is, I'm going to erase all of that coloring. I'm going to go back in and mark this one side, and I'm going to outline one of my triangles. And I have this angle and this one. So is the side that we have the side that connects the two? I'm going to pull that picture out of the way. Is this side, is that side that we know is congruent to the other triangle, the one that connects those two? And it is. So we're using angle, side, angle, because it's the side that's connecting the two angles. This says, can these two triangles be proven congruent with the information given in the diagram? And if so, which theorem would you use? So now we've got a little different information. You'll notice you have the arrows. So we know when we have the arrows that we have parallel lines. And we know when we have parallel lines, we look for what pattern? We look for the Z pattern to see if we have those alternate interior angles that would be congruent. So when I look, let's be sure we're looking at the right two triangles. So we've got triangle WXY. There's one of our triangles. And then we have triangle WZY. There's our other triangle. Oh, look, I overlapped. So what do we know about that side? Well, we know WY is congruent to itself because of the reflexive property. Now let's look and see if we have some angles congruent. Let's look for that Z pattern. Well, I can see it right here with angle 1 and angle 3 because those lines are parallel. So we've got these two angles congruent. Now, what about 4 and 2? Well, if you look sideways, because we have XW and YZ to be parallel, we have another Z pattern. So we have angle 4 and angle 2 congruent. This one is congruent to this one. Now that's a lot of markings and a lot of color. So sometimes it's good for us to pull aside and draw a picture without everything. So I'm just going to trace, well, let's see. I'm not going to trace. Whoops. Grab a marker. This is W, X, Y. And we've marked, this is angle 4 right here. This is angle 1. And then we said YW was congruent to YW. So since the side is the one that connects those two angles, we're using angle, side, angle to prove the triangles are congruent. Now I want you to take a minute, pause the video, and I want you to do problems 1 through 4. And then when you come back, we'll check them. Pause your video now. Okay, so you should have done those on your own and you're coming back here to check. Here are the answers. If there are any that you missed, come and talk to me about the ones you missed so that I can help you out. I'm going to stop this video here and we'll start the rest of the lesson on the next video.